Okay, you came back to learn more, and that's great. After learning about binary systems and understanding that everything has to be just changed to binary inside computer because this computer works with binary because of the hardware, uh, now we're just going to discuss about different types of data that we have gotten. Okay, and the first one, that is unsigned integers. Okay, so let's just discuss about what unsigned integers are. As you have obviously guessed, non unsigned integer is non-negative value. Okay, so an unsigned integer represents whole positive numbers with no negative attributes, plus minus sign. So data mapping, every isolated bit pattern translates strictly to a positive magnitude, changing to binary or things like that. Okay, and typically these unsigned integers are used for counting structures, for indexing, or for memory addresses where we do not need negative numbers. Okay, then positional value logic of this is just the same like a decimal system. Okay, uh, binary maps weightings based entirely on digit columns position. The first or the rightmost number is 1. Okay, the value of that is just 1. The next one is just the right of the left of that is 2. The next one is just 4. Okay, so columns step up exponentially from right to left. Base 2 rule, while Denary multiplies column values by 10, 10 to the power of 0, 10 to the power of 1, okay, or simply 0, 10, 100. Binary increases column values by powers of 2, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, which will just make 1, 2, 4, 8, 16, or things like that. We will be just discussing in the next slides. See, the core mechanism in base 10 or denary, so the place value of the first digit is just 1, then 10, then 100, then 1000, which is 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and 10 to the power of 3, which is just base 10. So we have gotten 10 here. In the binary or machine system, base 2, so here our base is 2, so that's why 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, which just starts the place values at 1, then 2, 4, 8, 16, 32, 64, and just so on, as you can see here as well. Okay, so values double with each shift left. 2 doubled 4, doubled 8, 8 doubled 16, 16 doubled 32. So just we have gotten that till the end. And decoding the machine or binary, or simply changing binary to denary. Okay, if we have just gotten any sequence of ones and zeros, 1 0 1 0 1 1 0 1, and we just simply need to know what is the value of that. Okay, so we have to use this method. Rule number 1, if the bit is 1, it means the switch is on, so you have to add the place value. It means we have it. Okay, here for example 32, it is 1, so it means we have one bundle of 32. Okay, 16 is 0, it means we do not have any bundle of 16. Okay, then 8 is 1, it means we have one bundle of 8, so we will just simply 8. If it is 0, the switch is off, ignore the place value. So here if the number is just given to us 1 0 1 0 1 1 0 1, and we need to just change it to denary, it is just very easy. Okay, so we will just write the place values 1 2 4 8 16 32 64 and 128, and whichever one is just 1, we will just add them together. So that is 128 plus 32 plus 8 plus 4 plus 1, that is 173. So 1 0 1 0 1 1 0 1 is equal to 173 in binary, in denary. Or just here, okay, it is just the same value, so we are just adding them. Okay, 1 1, then 8, then 4, then so explaining that better, see here, whichever value is 1, it means that is on, so we have to count that. So 128 plus 32 plus 8 plus 4 and plus 1, that makes it 173. See, in coding the machine, the subtraction method, okay, how we just simply do that, denary to binary. Now I will just change denary to binary. We have gotten a denary number and we want to just simply change it to binary. Okay, so we must fit the denary number into the available hardware slot from largest to smallest. So we will just start from the largest. If we can just make this place value out of this, we will just write here 1, otherwise we will write 0. Okay, and if we just made this, it means out of this I just took 128, I'll just simply subtract that. So out of 213, can I just make a 128? Yes, I can make. Okay, so it becomes 1, and subtract 213 minus 128, it will be 85. Now out of 85, can I just make a set of 64? So yes, I can. Okay, so again it will be just 1, and 85 minus 64, that will be 21. Now out of 21, can I just make 32? No, I cannot. Okay, so that will be 0. Again, because this is 0, no subtraction. Okay, now out of 21, can I just make a set of 16? Yes, I can. So that will be just 1, and 21 minus 16 will be 5. So we will have just 5. Can I just make a set of 8? No. Can I make a 4? Yes, I can. And 5 minus 4 will be 1. So 1 remains. From this 1, can I make a set of 2? No. And I can make a set of 1. Okay, so that is how we simply change the denary to binary, and at the end as well we will always have 0. Okay, so that is our number changed to binary. See, the subtraction algorithm start with denary number, then after that, is remaining value larger or equal than the place value that we are just deciding about right now? If it is, it means we can just have that number, set the bit to 1, and subtract place value from remaining value, and after that move to the next bit. If it is not, simply set bit to 0, then no subtraction, move to the next bit, and just again do the same thing. Okay, repeatedly we will do the same thing. So it is very easy to change denary to binary or binary to denary. Okay, practice a lot. Discussing about system limits and information capacity. Okay, so according to the number of bits that we will have limits of numbers. Okay, or we will have just a specific range that we can store inside that. Outside that range we cannot store. Okay, so mostly we will be working with 8 bits. Okay, in 8 bits the smallest number is just all of them 0 0 0 0. It means all of them are off, so it will be 0. And if we just simply change all of them to 1, turning each transistor on, so that will be 8 ones. And if you just simply change it to binary, that will be 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. That will just be 255. Okay, so see, before we have just studied about this, we can just make 2 to the power of n different patterns or combinations from n bits. So if it is 8, so we can make 256 unique patterns. So we have gotten 255. It means 1 up to 255, and 0 is also counted there, so it will be 256 different hardware sets. So that can be just a exam question. Okay, so the maximum number that you can store inside 8 bits is 255, but the number of different combinations or different values that you can store, that is 256, because 0 is also counted. So be careful about that. Okay, in exams, do not make that mistake. The operators manual exam parameters. Okay, you have to just be careful in your exams. The first one, doing mental math, that is just not good. Okay, always physically draw the 8-bit place value table on your paper. Write 1 2 4 8 16 32 64 128. Okay, always do that and just use that to change. Mental math, you might be just sure, but we are human. Okay, we are prone to just make mistakes. Reaching for calculators. So calculators are strictly forbidden inside the exam, so you have to just get used to do this calculations on paper. And leaving empty left side spaces in exam, mostly we are just having what, 8-bit binaries. Okay, so in 8-bit binaries, if you just change a value to binary and just simply you fill 4 5 or 3 bits, the remaining bits you have to just add zeros there. Okay, to be just make it complete 8. So write 0 0 0 0 1 1 0 1 instead of 1 1 0 1. Okay, so you have to just add those zeros there. some questions. Okay, convert the Denary number 79 to 8-bit binary, and convert the 8-bit binary pattern 010011100 into a Denary number. So you can pause the video, solve this question by yourselves, then just play the video and check if your answers were correct. Okay, and if it was correct, so well done. If not, then just look and find your mistake. Okay, and learn from that. So 79, so we cannot make 128, but 64, yeah, we can make. Okay, so that will be, the first one will be 0, 128 we cannot make, 79, so 64 minus it, then we will have 15. Okay, so we cannot make 32, we cannot make 16. Then we can make 8, so that is 1, 15 minus 8 will be 7. Then the next one, 4 out of 7, yeah, obviously we can make 4, so again that is 1, and 7 minus 4 is 3. Then the next one, 2, obviously out of 3 we can have just 2, so 1, so 2 minus 1, 1, and yeah, we can just have the 1 as well. So that is just our final answer. If your answer is the same, well done. If not, then just see where you just made mistake. Convert the 8-bit binary pattern into a Denary number. So again, this is just the number 001100010. Write the place values, and just whichever one is 1, you have to just add them together. So 64 plus 8 plus 1, that makes it 76. That is just your answer. The next question, identify the number of unique binary patterns that can be represented by exactly 8 bits. So by 8 bits, 2 to the power of 8. 2 to the power of 8 will be 256. So that is the correct answer. Okay. And state the maximum Denary value that can be represented by an 8-bit unsigned integer. So the maximum unsigned value that you can store in 8 bits, that is 255. Okay. Because 0 is also counted there, the unique patterns will be 256, but the maximum number is 255. So that's it. Okay, wish you all the best. I hope you have learned. Okay, solve some questions, write some binary patterns on the paper, change them to Denary, and just change some Denary numbers to binary. Okay, wish you all the best. Good luck and goodbye.